Hello everyone, my name is Westfechtel from the University of Tokyo, and I would like to present our paper Backprop Induced feature weighting for adversarial domain adaptation with iterative label distribution alignment. So for the motivation to train deep neural networks, it requires a large amount of labeled data, but to get the labeled data is tedious and very costly. So one solution for it is domain adaptation, where you transfer the knowledge from a labeled source domain to an unlabeled target domain. And this is often done by extracting domain-invariant features, so features that are discriminative for both domains. This is often done in an adversarial way. However, one of the problems is that also the background features get aligned. So here in the first row, you see some images, and in the second row, you see a heat map of which features are aligned. And you can see that, for example, here for the TV, it doesn't really focus on the TVs. And so that's where our first contribution sets in, the Backprop Induced feature weighting. And we backpropagate the gradients from the classifier and then reweight the features based on it. And we can show that we, with this, focus much more on the foreground. The second contribution of our paper is tackling the label distribution shift. So in the data sets, the samples are not equally distributed over the classes, and this harms the accuracy. A class-balanced data loader would alleviate the problem, but especially for the target data, we don't have the ground truth classes, and so it's hard to implement. So that's why we introduce an iterative label distribution alignment. So we train the network several times and use the predictions of previous runs as pseudo labels for the data loader. And so with this, we can have a relatively robust, relatively class-balanced data loader even early on in the training. So the contributions, the backpropagation guided weighting, the iteratively label shift alignment paradigm, and then we show the effectiveness on 3 different data sets. This is our pipeline where we have the classification loss, which we then backpropagate to reweight the feature space, the adversarial loss, and the semantic loss. And then we train it several times from scratch and using the predictions in order to get a class-balanced data loader. We did experiments on 3 different data sets of 31, OfficeHome, and DomainNet. And we can show that we achieve higher results than other methods, and also that the iterative approach also further increased accuracy. These are the results from Office 31. Here are for OfficeHome. And then we also show the increase from the iterative label distribution alignment. And if you're interested, I would please come to my poster and we can talk more about it. Thanks for listening.